In this example, we're asked to find the phase, so liquid, saturated, liquid vapor mixture or vapor. We're trying to find what phase the water is in for the following conditions. So we have, what is this, 6 different conditions that we're asked to find the water phase in. So the first one is a temperature of 24 degrees C and a pressure of 0.1 bar. And to define these, I'm going to not use a blank piece of paper here, but I'm going to actually just go from the solutions. And the reason for that is because we're going to refer to some tables, so it's just easiest to do that. So when I look at this first one, we have 24 degrees C and a pressure of 0.1 bar. So what I'm going to do is go to the saturated liquid vapor mixture table, organized by temperature, and I'm going to just see at 24 degrees C what the saturation pressure is, and then compare it to this 0.1 bar. So let me go find the table. So here we are. This is the properties of saturated water, liquid vapor mixture, organized based on temperature. That's the first column. This table comes out of Moran et al. I guess I don't have the reference here, but it's Moran et al. 7th edition, I believe. So anyway, we said that we were dealing with temperature of 24 degrees Celsius and a pressure of 0.1 bar. So the pressure was 0.1 bar. But you see here the saturation pressure corresponding to 24 degrees is roughly 0.03 bar. So this pressure is a lot less than the current pressure of 0.1 bar. So what that means is our pressure is higher than the corresponding saturation pressure. So that would mean that the water is in a compressed liquid state. And because the pressure is higher than the saturation pressure. So we're compressing that water, we're squeezing that water, so it's not in a saturated liquid vapor mixture state, but we've squeezed it into a compressed liquid state. So if we sketch out what that looks like on, let's say, a PV diagram, or I guess I did it here in a TV diagram, looks like this. So here's our vapor dome. So we've got temperature as a function of specific volume, our vapor dome. I've drawn the saturated vapor state in red line and the saturated liquid phase in the blue line. And I've drawn a couple of isobars here. So the isobar corresponding to 24 degrees C, that saturated pressure isobar is at 0.02985 bar. So that's this one right here. Note that these are all absolute pressure. So you can see at 24 degrees C, there's the pressure corresponding to the saturation pressure. By the way, I know that isobars go from the bottom left to the upper right. The little mnemonic I use is this. When I write out isobar, if you look at the R, you see it goes up at the end. So that makes me think of going from bottom left to upper right, just like the R goes from bottom left to upper right. Okay, just a little mnemonic. Now I'll draw in the isobar for 0.1 bar, and of course isobars increase, the pressure increases going that direction. So here's my isobar for 0.1 bar. So then if I see where 24 degrees C crosses the 0.1 bar isobar, you see it hits right there, and that puts us in the compressed liquid phase. Remember, this is saturated liquid vapor mixture here, and this is superheated vapor over there. So we quickly see that we're in a compressed liquid phase for this particular case. All right, let's move on to the next one. A pressure of 4 bar and a temperature of 180 degrees C. For this one, I'll just go ahead and look at the saturated liquid vapor mixture table organized according to pressure, because this is just a nice even number, 4 bar. I could use that. I could also go to the one organized according to temperature and look at 180 degrees C, but for this one, I'll go to the one based on pressure, so 4 bar. So let's go down and look at that table. Here we are. So here's the saturated liquid vapor mixture table based on pressure. You can see this. These are absolute pressures. Again, this table comes from the Moran et al. Text. So I'll go down to 4 bar. Here we are. The corresponding saturation temperature is 143.6 degrees. Remember that our temperature that we're interested in was 180 degrees Celsius. So that temperature that we have is higher than the saturation temperature. So that means that since our temperature is higher, we're going to be in a superheated vapor state. This 143.6 is when it's just starting to, it's a mixture of liquid and vapor in here. We're under the vapor dome, but our temperature is higher than this, so we've gone all the way from saturated liquid vapor at 143. Now we're just dealing with superheated vapor. So let's go ahead and plot that one out. So let me go back up here. So that one I'll plot on a PV diagram just as an example. So here's pressure and specific volume. And here's our pressure of 4 bar. The saturation temperature isotherm of 143.6 is shown right here. So that's the isotherm at the saturation temperature corresponding to 4 bar, right? Because that isotherm, that's the temperature right along that horizontal line at 4 bar. And when you have, and by the way, the way to remember that isotherms go from the upper left to the lower right is the way I remember that. The mnemonic is when I write out isotherm, helps to write it correctly. When I write out the M, notice that the M, the very last part of the M goes from the upper left to the lower right, just like an isotherm. So that's how I remember that. So isotherms increase as you go this way. So if this is 143.6 degrees Celsius, if I draw the one for 180, it'll be above it right there. And you'll see that that crosses the 4 bar out here in the superheated vapor phase. Okay, so now we're going to be dealing with superheated vapor for that particular case. Okay? All right. And just if you wanted to see what it looked like on a TV diagram, let me just quickly sketch that one here. So here's specific volume. Here's temperature. I'll draw the vapor dome here. Let me draw in a couple of isobars. So we'll call this I'm just going to draw a couple of isobars here. And we'll say that for 4 bar, we'll make this one 4 bar here, and the corresponding temperature for that would be the 143.6 degrees C. And then we're at 180 degrees C. I'll just draw that up here, 180 degrees C. Actually, let me get rid of that second isobar. It just clutters things up. But, this is our saturation temperature of 143.6 degrees corresponding to 4 bar, that isobar. But we're really at 180 degrees C. So I'll just draw that temperature coming over. And you see, again, it intersects in the superheated vapor phase region. Okay? So that's what it would look like on a TV diagram. You can do these on PV or TV diagrams. You'll still get the same phase. So let's go to part C. That one is 20 bar and a specific volume of 0.01. Okay, so for that one, I'm going to go to the saturated liquid vapor mixture table organized according to pressure, 20 bar. So remember these numbers, 20 bar and 0.01 for the specific volume. So let me go to the saturated liquid vapor mixture table organized according to pressure. We're going to go down to 20 bar. I think that's what we said it was 20 bar. Let me just verify my notes in just a moment. Yeah, 20 bar. 20 bar is actually this table right here. So I've got another box there, but this is 20 bar that I'm boxing in. And our specific volume is 0.01. So if you look at this one, that specific volume is, remember that these specific volumes are multiplied by 10 to the third. So this one really is 0.001767 cubic meters per kilogram. So that's what this value is right there. And then our other specific volume, or I'm sorry, that's the specific volume corresponding to a saturated liquid. And then, oh yeah, here's the saturated vapor one is right here. Notice the saturated vapor one is not multiplied by the 10 times 10 to the third. So the saturated vapor one is just 0.09963. So that's just that one. So our actual specific volume was 0.01. So we're somewhere in between these two values, right? So 0.01 falls in between those. So that means that we're under the vapor dome. We're dealing with a saturated liquid volume mixture because our specific volume is somewhere in between those values at our given pressure. Okay, so let's go ahead and sketch that one out. So here we have our vapor dome. I'm just plotting this one on a PV diagram. Here's our temperature, or I'm sorry, our pressure of 20 bar. Sorry, this doesn't line up very nicely. I should probably put it this way. Okay, ignore that line. So our 20 bar line is right there. Here's a corresponding isotherm. If you go back down to that table, see the saturation temperature is 212 degrees C. So let's just go back and just show that. At 20 bar pressure, 212.4 degrees C is our saturation temperature. So that's the isotherm corresponding to that pressure. And then our saturated liquid specific volume from that table we said was this 1.1767 times 10 to the minus 3. Again, just going back down to this table. Sorry, I'm probably making you dizzy. It's this value right here or this one right here. And then the saturated vapor specific volume is 0.09963, which is this one right here. So that is given right up here. And then our 0.01 is somewhere in between there, so I'll just draw it right here. So that's where we are. We're in a saturated liquid vapor mixture, or this two-phase saturated state. That's the phase that we're in. Okay? Let's move on to D. Case D is temperature of 30 degrees C, and this pressure of 0.04246. So this one I'll go to the saturated liquid vapor mixture table, organized based on temperature, since it's a nice even number there, and then look to see what the corresponding saturation pressure is. Okay, so let's go to that one. So here's our saturated liquid vapor mixture table for water based on temperature. So it's based on temperature here. We said it was 30 degrees C. And look at our pressure here. Our saturation pressure is 0.04246, which is the pressure we were given. So we know immediately we're in a saturated liquid vapor mixture phase. Okay, so we know then, if I sketch this out on a TV plot, here's our vapor dome. 30 degrees C is what we're dealing with. Our corresponding pressure is right here. That's an absolute pressure. So there's our isobar for that. And so we're somewhere in here. We're in a saturated liquid vapor mixture phase. We're somewhere in here, but we don't know where exactly, right? Because it's at that given pressure and temperature, there are multiple specific volumes we could have. We don't know exactly where we are in here. We would need additional information to figure out where we are. That additional information could be like a quality, which we haven't talked about yet in lecture, or it could be like what's the actual specific volume, or maybe what's the specific internal energy. Some other piece of information to nail down where we are exactly. But all we can say at the moment is we're under the vapor dome in the saturated liquid vapor mixture region. Okay. And again, if you wanted to see what that looked like on a PV plot, let's just sketch that out quickly here. Specific volume, pressure. Here's our vapor dome. Our isotherm would look like this. This is the isotherm at a temperature of 30 degrees C, and the corresponding the corresponding saturation pressure for that would be the 0.04246 bar. And then again, we're somewhere in here in the saturated liquid vapor mixture phase. Okay, let's go on to E. For E, we're dealing with a temperature of 30 degrees C and a specific volume of 1.0043 times 10 to the minus 3, so we'll try to remember those numbers. And then let's go again to the saturated liquid vapor mixture table based on, or organized based on temperature. So we go back down here. Sorry, you're probably getting dizzy from going back and forth so much. So saturated liquid vapor mixture table organized according to temperature. Here's our temperature of 30 degrees C. If you look at the specific volume, here's our saturated liquid specific volume, 1.0043, and then remember this is times 10 to the minus 3 to get there, so let me just make a note of that, 1.0043 times 10 to the minus 3 cubic meters per kilogram. So that's this value right there, and then the the saturated vapor at that temperature has a very large specific volume, 32.894. Remember, this one's not multiplied by 10 to the third. That's just the number, 32.894. Okay, so we were told in the problem statement that our specific volume was actually 1.0043 times 10 to the minus 3. So we're right there. We're actually in a saturated liquid state because it corresponds to that. So when we draw that on our diagram, so this one is E here. So here it is on a TV diagram. This is our saturated liquid line. That's our saturated vapor line. Here we are at 30 degrees C. Here's our isobar corresponding to the saturation pressure. All right? And our specific volume is right there. That's the 1.0043 times 10 to the minus 3. So we're right there on the saturated liquid line. And if you wanted to see that one on a PV plot, it looks much the same. Here's our vapor dome, our isotherm, corresponding to, this is our 0.04246 bar. Our corresponding saturation temperature for that would be 30 degrees C. And our specific volume of 1.0043 times 10 to the minus 3 cubic meters per kilogram, corresponding to the saturated liquid state right there. Okay, now the very last one is, go all the way back up here, is the pressure of 25 bar and a specific volume of 0.07998. So that one I'll go to my saturated liquid vapor mixture table organized based on pressure, because 25 bar is a nice even pressure to use. So let's go all the way down for that. So that's this one. Let me erase the other markings so it's clearer. So it's the one that's boxed in red here. So there's 25 bar, saturation temperature is 224 degrees C, and our specific volume for the saturated liquid state would be 1.1973 times 10 to the minus 3. That's that one. And our saturated vapor specific volume is 0.07998. But if I look at that, this is the number that we were given for our specific volume. So in this case, we're actually in the saturated vapor state, or saturated vapor phase. So if we sketch that one out, that's this plot. So here it is on a PV diagram. Here's our 25 bar. Sorry, the line isn't meshed up perfectly there. But there's our 25 bar. The corresponding saturation temperature is 224 degrees C. So that looks like that. That's our isotherm. And then our specific volume was the 0.07998, which corresponds to the saturated vapor phase, that red line right there. And if you wanted to see it on a TV plot, just as a supplemental plot, so the temperature is 224 degrees C, corresponding isobar would look like this. This is our pressure of 25 bar, and there's our saturated vapor phase value right there. This is the 0.07998 cubic meters per kilogram. So that's where we are on a TV diagram. All right, that covers all of the different parts that we were asked to find, so we'll end it there.